Leonard obtained his PhD at 2011 in the Max Planck Institute for Astronomy, and then worked as a postdoc in the Max Planck Institute for Stellar Physics, working with the gravity instrument. Since 2017, he is a staff scientist at the Leiden Observatory in the Netherlands and works for the ELT instrument METIS as a calibration scientist. Leonard is also a key proponent of the sustainability development of one of the founders of the Astronomers from planet Earth, one of the movements uniting educators and scientists around the globe to share their astronomical perspective about the Earth and climate change with the public. He will give us a talk on climate change from an astronomical perspective. Leonard, the floor is yours.
Thank you very much, Yara and Carla, and everyone for organizing this wonderful session and for having me here. It's a pleasure to talk about, well, it's a pleasure still to talk about the topic, although it's of course a sober topic, and it's good to see some people and faces and names who I recognize from various work relations with Chile. So this talk will be about astronomy and the climate crisis, and I've been asked by the organizers to structure it roughly in this way. So first, I want to talk about astronomical influences onto our climate. So where is astronomy actually a relevant factor for our climate, and where is it not? Then coming to a brief overview of the anthropogenic climate crisis. I guess most of you know the facts, but it's still good to just keep them in mind and refresh our minds regularly. Then a very brief summary of astronomy's carbon footprint. Brief because we will hear from Adam Stevens in a much more elaborate way in the second part more about this. And then what can astronomers actually do? So pretty much along the lines of what Yara said at the beginning, just expanding a bit on this. So yeah, what is the influence that astronomical factors have on the Earth's climate? Well, obviously it's enormous. I mean, this is certainly no surprise for everyone here. We're talking about habitable zones. There are galactic habitable zones. There are circumstellar habitable zones. And we can be quite lucky on Earth that we have a relatively boring star and a relatively boring galaxy that we live in, so that complex life had the time to evolve to where it is right now. And there is, of course, this so-called Goldilocks or habitable zone around a star, and our planet happens to be there. So that's all very important. We have a large moon that stabilizes our orbit, and also Jupiter probably helps to keep away some of the more dangerous asteroids from Earth. So that's all well and good. There's a really nice book about this hypothesis called the rare Earth hypothesis, that, well, there might be life in many places of the universe, but only very few places are lucky enough to have the stable conditions over billions of years so that complex life can evolve. So that's all very important. But let's look at changes of the climate and at shorter timescales. Well, also there's pretty strong evidence that astronomical factors can play a role or do play a role in the change of our climate. So for example, there are the Milankovitch cycles proposed by Milankovitch in the early 20th century. And he compared the changes in the global Earth temperature. There were already the first reconstructions at the time with changes in the Earth orbit. And you can see perhaps here in the left panel, the changes in what's called delta O18, so the oxygen, the 18 nucleotide isotope of oxygen, which is an indicator essentially of, or a proxy for the temperature on Earth. And you can see that this can be studied back 600,000 years or so. And we see these temperature changes that, of course, correspond to the ice ages that are well known across the globe. And then you can do a Fourier transform of that essentially, and you find that the most power in this variation is at cycles of about 0.01 per kiloyear, so every 100,000 years. And that's precisely what we know as the ice ages that happened in the last million years, every 100,000 years roughly. And that is most likely related to variations in the Earth's orbital inclination. So that is, I think it's still not fully clear why that is, but there is a very obvious relation between changes in the Earth inclination, orbital inclination. So that is pretty obvious. But then let's come to even closer and shorter timescales. Then we have the sun with its 11-year cycle or 22-year cycle. Every 22 years, it's from north to south, the magnetic field, and then back from south to north. as you know, and this leads to a change in the number of sunspots. This has been observed first by Galileo Galilei already, who ruined his eyes by observing this. Nowadays, it can be done a little bit more safely, but it's very well established, this 11-year or 22-year cycle. And some people think it might have something to do with climate change as well. But we will see whether that is the case or not. Certainly, there are proponents who would like to link what is called the Little Ice Age. That's a period that had lower temperatures, mostly in Europe and also Northern America. At what you see here, middle of the 15th century until the early 19th century, where the temperatures were a little lower than in the few hundred years before that. And there is this link that some people like to see between the sunspots and this little ice age. So particularly the so-called Maunder minimum, which was observed by a couple in Ireland called Maunder. There were also previous minima observed by other people, and later ones, as you can see. And this Maunder minimum is actually only a small part of this little ice age. So you can already see from this that it's that this alleged relation between the sunspots and the global temperature is not that obvious, actually. And indeed, the most, for some of you, this might not mean something because you might have perhaps not heard of this, but this is one of the prime cases where essentially climate deniers try to make the case that sunspots are important for the climate on Earth. And I might have given the wrong introduction, but of course it was deliberate. So there are astronomical factors, and here we have clearly factors that do not play a role actually for our climate. So it is quite interesting to see the changes in the solar cycle, of course. But the Little Ice Age began well before the Maunder minimum and also lasted a lot longer. And the best case or the best hypothesis these days for what this Little Ice Age was, which, as I said, was actually not global, but just in the northern Atlantic region. And it's also only a dip of a couple tenths of a degree, while real ice ages were global and had changes of a couple of degrees, 3 to 4 degrees typically. This is most likely related to volcanic eruptions, as we just have seen the past few days with the Hunga Tonga explosion that happens frequently on Earth, and that can certainly lead to a small dip in the global temperature and can also last for quite a while until the dust settles again. There is, if you want to go into more details about the Earth climate history and its relation or not to the sun, there's a really nice introduction or compilation also of the literature in one of the many reports that the IPCC, the International Panel on Climate Change, produces. I'll leave the link here and you can look it up later if you want. But what about even more recent times? So there is, even now, you can compare the solar irradiance here in yellow with the global average surface temperature in red here. And until the year 1960, there was this remarkable trend that both were increasing. So the sun was increasing its irradiance and the global temperature was rising a little bit already. And this led, again, many people to say, oh, but now it's really the sun that's actually causing this. And people who give talks about this these days often just show you the data until 1960 or 1970, because if you look at it until 2015 or something, 2019, even the latest that we have, then you clearly see that these two curves diverge and have nothing to do with each other. But of course, there is also a much more scientific way these days to compare these numbers. So the IPCC in their latest report last year did a very careful compilation of studies that modeled all the natural behaviors, all the natural changes that have an impact on the climate. So the sun, volcanoes, anything else that might play a role, and predicted, so to say, post facto, what change in temperature would that occur to. And this is the green line in the right panel here. And you see there are changes, there are also uncertainties, as in every scientific model. But clearly the change in global surface temperature that we observe since about 50 years or so, which is now about 1 degree, is not explainable by these natural factors. So that there must be something else, and this something else is us. So what is then what is it then really? Well, it's this really unprecedentedly high levels of CO2 that we observe in our atmosphere. So the red point is roughly where we are at the moment, 416.7 parts per million CO2. If some people tell you, well, parts per million, that's not a lot, then just ask them to swallow down 416 ppm concentration of arsenic in their water. They will probably not do it. So even a small concentration of something that has a big effect can lead to something substantial. So this is really a concentration of this greenhouse gas that hasn't been seen before, at least not in the couple 100,000 years of recent Earth history. And it leads to increased temperatures, and that again, as we know now, leads to increased natural disasters. Of course, not every natural disaster is related to climate change. There are also other reasons. They happened before, that's all clear, but it can now be pretty solidly attributed to climate change. So for example, the immense flooding that happened in summer last year in Germany, the Netherlands, and Belgium would very likely not have happened at a temperature with the pre-industrial climate. There's models now that compute these differences, and that's almost not explainable with a pre-industrial climate. We can also look at this very nice realization to see what we actually need to do. So this is the carbon bucket, explaining how much CO2 we can emit for the Earth climate to warm up by 1.5 degrees and not more. This is the level that is typically seen as acceptable, where not too much will happen. And you see this bucket is quickly, very quickly filling up. In the year 2019, well, that's 3 years ago now, only 9% were left, or 10 years. This relates to the number that Yara said in the beginning. So we really need to act very quickly now. And you might say, oh, there was the Glasgow COP just in November last year. Everything is solved now. Unfortunately not. I'm very optimistic. It is hope. Then you see this optimistic scenario where we will end up with 1.8 degrees warming until the end of the century. That would be really good. I mean, it wouldn't be as good as we want. 1.5 would be much nicer. It would leave some margin to all these tipping points that we don't really understand. But that's unfortunately a very optimistic scenario. And even if you look at the pledges, then you don't quite get there. It's at 2.1 degrees at the moment. And if you look at the actual targets, so what is actually already in place and not just promised for a future where the current politicians are not in power anymore, then we're already at 2.4 degrees. And if you look what is currently the law, then we're at a range between 2.5 and almost 3 degrees, which is clearly too much. We already see the effects now in a just 1 degree too warm world, and that is already pretty dramatic in some places. So we certainly don't want to imagine what would happen if the Earth warms up. But the good news here is the really extreme scenarios of like 5, 6, 7 degrees warming, they are pretty much away now. So this is really, I see this as really optimistic news. We can do something about this, and we are doing something about this. And it just requires a bit more, well, a lot more, but it requires something that we can do to get us onto one of these, whatever color that is, optimistic scenario or 1.5 degree trajectory. This is certainly possible. So what does this all have to do with astronomy? I mean, we're studying galaxies and stars and planets. What's the relation to astronomy? I think there's two very significant relations. One is we have a gigantic carbon footprint ourselves, and we need to reduce it for moral reasons, but also for the sake of our own discipline, and we need to lead by example. And also we have a very, very strong outreach potential, and many of us are using this, of course, talking with the public, and we can use that to convey how special our planet is and why we really have to act it, because it's the only planet that we have. So very briefly about our own carbon footprint, as I said, Adam will go into much more details about this. Just to mention here, the most significant emissions that we produce come from production, generation of electric power, and from flights, and in that case, mostly long distance flights. The precise share of what it is depends on the country, depends whether you are an observatory, then you need lots of electricity, or if you're an institute, then you need to travel to the observatories. But in any case, these are the two major parts that we need to fix first, and then we can discuss about plastic cups and other things. The flights are really a big issue, because it's not very easy to replace a flight, at least a long distance flight. And the long distance flights are the ones that matter. We looked at this for astronomical conferences. We also looked at this for flights for the Leiden Observatory staff, just before Corona, of course. And you see, for example, here that the blue line, which if you can see my cursor, this is the number of trips So about 50% of all trips, air travel trips from Leiden in 2019 were less than 1,000 kilometers. They can easily be replaced by train in Europe, but they are not responsible for most of the emissions. Most of the emissions come from trips that are beyond 8,000 kilometers, and there's unfortunately no train to Chile from Europe yet. Or, I don't know, there will ever be one.
2 minutes, Leonard.
Thank you. So can we do more? I think so. There is no planet B is one of the strongest signs, one of the most frequent signs you can see on climate rallies. And we are the discipline that understands that, right? This is an astronomical message. We know how many exoplanets there are, and there's none yet, and there are certainly none in reach for us where we could live. And by the way, even if there was a planet B, and even if we had the means to get there, who knows if the folks there would really like us? You know, it might be inhabited, and then perhaps we shouldn't bother them. So there is no planet B. That's one message, one important message. But also we can just show the facts. We know how to read scientific literature. Even we can read some reviews about climate science to at least get our background knowledge, and then present some core astronomical news or science results like the solar irradiation. But perhaps even more powerfully, we can present this perspective. This Earth is a planet. It's not just, you know, what you see around you. It's not just streets and cars and cities. It's a planet. It's a lonely small planet in a big universe. And we are really so lucky to have this one space where we can live, and there's really nothing else. Of course, you all know this fantastic pale blue dot image from the Voyager 1 space probe taken after it visited the outer planets when it turned back to Earth and found this 0.2 pixel big speck of light, which is us. So that's, I think, always, again, very impressive. Now, before finishing, let me just show you, if you engage now into climate science, who do you need to engage? Should you try to convince the few people who say, oh no, it's all the sun, or it's not real, or it doesn't matter? Is that important? Or should you rather convince those who already know that climate change is a problem and try to motivate them to become active? There is this very nice survey done by the Yale program on climate change communication, and they categorize, in this case, people in the US, but it's also done globally, very similar picture. How would people see themselves in terms of climate change? And interestingly, very few people say it doesn't exist, or I don't believe it, or I don't care. Most people are actually either alarmed, they already know it's a big problem, they're concerned, or cautious, which means in this case, they're not quite sure yet how big a problem it is, but they certainly can be convinced. So I would say, target your communication to the cautious ones and try to get the alarmed and concerned ones really active, because together, this is more than 50%. This is way more fraction of population than we need to do the political changes that are now required to make sure that we get onto this 1.5 degree track. That's it from my side. There is the organization that Jara and Carla already mentioned, Astronomers for Planet Earth. You're all very welcome to join it if you haven't done so yet. We have so far only very few people who joined us from Chile, and you're all very welcome to join us too. We have mailing lists, a Slack space, lots of resources. We're building a fantastic new webpage to showcase everything that we have. We're coordinating talks and activities, and of course, lots and lots of also scientific articles. I'll leave you with a summary, and thank you for your attention.
Thank you, Leonard. A really nice slide about to target your talks and your speeches. We have a question here from Marcelo Mora. He asked about the possibility of change in such a way that it settled down in a new stable state.
Well, yeah, I'm not exactly sure what the question is, but if these tipping points become reality and we do change the world into a state where it hadn't been before, then there will likely be another, let's say, stable point in, I don't know, a few hundred years when we have hopefully stopped emitting. But I think no one really knows where that point is and whether it will support 8 billion people and feed 8 billion people. I mean, that's the problem, right? Climate change will not destroy Earth. It will also not destroy human life or life together on Earth, but it might destroy the way we live together. That's the real problem. Yeah,
and it's also a chaotic problem. So at the end, it's a wicked chaotic problem that you don't have the tides to know if the if the equilibrium are going to be achievable in the future or not regarding your actions. We have another question from Elizabeth Arthur de Villarmón. Do you think the pandemic situation helped in decreasing the CO2 emission?
It did. Yes, the pandemic, of course, is a tragedy for very many people. That must not be forgotten, but it also definitely has some chances for development. The emissions in 2020 were about 8% lower than in 2019, which is good, but not enough, of course. And also, we don't actually want to reduce emissions by, not being able to go out anymore and not seeing friends anymore. That's not the way we want to solve the climate crisis, and also not how we have to solve it. So there's, I think what it shows us that even due to the almost near lockdown of the whole world for some months, not being able to travel, not being able to see people, that had an 8% effect. So we need to do both more and less. We don't actually need to stop seeing people. Perhaps we shouldn't be flying around too much. But there's other things where we need to become active, like stop burning coal and obviously reducing burning oil and all the other fossil fuels.
I have another question here. Do you have any materials in Astronomer for Planet Earth that can be included to prepare outreach talks, for example?
Yes, we do. So if you sign up for A4E, I mean, it's free. It's essentially you're signing up for a mailing list and you get an invitation to our Slack space. If you do sign up, you can also get access to our Google Drive and soon our new webpage with lots of content for members. We have slides for you. We have, slides that members prepared, other people like you and I prepared. And also some material. We have several videos that you can use for your both outreach and professional astronomer talks.